Okay. Hello, everyone. Thanks for tuning in. My name is Ralf Kühnert. I'm welcoming you today to Square's Brainfood Talk session. Today we're talking about slicing microservices efficiently. This is a part of a monthly series that we're hosting as part of our internal Brainfood initiative, where we try to consistently further our own knowledge about topics. And once a month, we try to produce a public session, a public stream, which you have just tuned into, to share some of our ideas and our knowledge with you guys. I want to introduce you today to Clemens Stift. He's a senior engineer here with Square, an expert in growing up in the microservice native world. He will lead you through today's session. And afterwards, so we have the talk session segment first, where Clemens will share his ideas with you. And in the meantime, if you have any questions, just please post them in chat over on the right-hand side of your screen, and I will collect them. And afterwards, we have a Q&A session where we will handle some of those questions. Cool. And with that, I would like to hand over to Clemens. Take it away and have fun with today's talk.
Hello, everyone. I'm excited to be able to share our learnings here at Square on how to slice microservices efficiently with you today. Before we get into the topic, I have two disclaimers. We only have 30 minutes here, so there will be some simplifications and a couple of details will fly under the radar here. And as always with architectures, there are no silver bullets, right? Everything is fraught with trade-offs, so you need to choose the thing that is right for the job. Now, when we start to talk about slicing microservices, we need to think about what we actually expect from a microservices architecture. And to do that, we need to put it into comparison with our other architectural styles, which I have tried to chart out here from left to right by the strength of their architectural boundaries that they impose. On the left side, we have our monolith, which has over the past couple of years gotten a bit of a bad rap. But it is not all bad, right? So it's a familiar development model, and it is very easy and fast to get started with. And the pain with the monolith comes once it grows to a certain level of complexity where it becomes hard to maintain the modularity. And with that, it becomes hard to develop independently when you have multiple teams working on it. In addition to it, with it being just one compilation unit and therefore also one deployable unit, you do not really get the independent deployment and scaling that we oftentimes expect in today's infrastructures. Also, an issue with it is that you have very little fault isolation. So if one of the features one of your teams develops introduces some kind of memory leak, you will feel it across all features, right? The solution must not, or it does not have to immediately be microservices, right? There's something along the way too. For example, the modular monolith. In this concept, you have multiple compilation units, which therefore are strongly decoupled, and they increase the team autonomy. So you could have, in the Java world, for example, you could have multiple teams working on individual features, have them package those up as jars, and then use the Java Jigsaw module system to put them back together and have one releasable, deployable unit. With that, we usually do that once our application has reached a certain level of complexity and where the modularity starts to break down. And this helps us enforce modularity again. But it also introduces what's called accidental complexity here. Complexity that is not due to the business logic itself, but due to now using a module system. It also still is fraught with the same limitations in terms of deployment and infrastructure, right? We can't have independent deployment and scaling, and we still have little fault isolation. It doesn't matter if jar number 2 introduces the memory leak, since it's in the same runtime, it will have the same issues. And now if we want to draw these boundaries even stronger, and we want to deploy multiple runtimes, then we're in the world, or we get into the world of microservices. They're strongly decoupled. They allow teams to work highly autonomously. And in contrast to the modular monolith, they're also independently deployable and scalable. And they're also technology agnostic. So you can have one team developing Golang, the other in PHP, the third in Java. And they're also highly fault tolerant. Notice the asterisks on all of these. You get all these benefits if you structure them right. We will get to that in a minute, right? Of all the 3 options here, though, they're the ones that come with the highest level of accidental complexity. So you will have setup work to do in terms of integrating these services. You have a more complex deployment model. You will probably need some kind of API gateway or some reverse proxy. You will probably have some code duplication, which is not always a bad thing, right? It allows us to stay more decoupled. All in all, what we can take away from here is, there is no silver bullet, right? You should go for microservices if these upsides of the microservices solve a pain that you're experiencing, right? Now, that being said, let's get into actually slicing them. And to do that, we need to get ourselves into some kind of context. And here, for this, I would like to say, or like to assume, that we are an e-commerce site. Let's say we're similar to Amazon. We call ourselves Vienna Amazon or something along those lines. And we are planning to be the next big thing, right? We will grow fast, both in terms of features and in terms of headcount. That is why we want to use all those upsides of microservices. And we're really happy that after a couple of days of discussing about it, we decided, okay, we're going to do microservices now. So we sit down together with the team and we think, okay, like, what are the boundaries we're going to draw? How do we slice those things? And then we come up with our initial structure. We decide, okay, we're going to have a UI and we're going to have an API gateway, because otherwise the UI would need to talk to multiple independent services. We don't want to leak that knowledge into the UI. And we will have services that are cut around the entities that we need inside of our business. So we will have a user service, a product service, and an inventory. So we'll have both vendors as users and customers as users, and we have products to sell, and those products have a stock and inventory somewhere, right? Makes sense. It's kind of logical to go down this route. Now, entities alone will not sell units, right? In the end, somebody comes along and says, hey, this is very nice architecture. Can we start selling things to users now? How can they order? Where do we put the ordering logic? And now we go back to our drawing board and we start looking for a place to put this ordering logic. And so we go around and we try fitting it into different places. And the first place we're trying is we think about, hey, can we put this into the UI somehow? Or can we, not into the UI, but can we put this into the front-end code somehow? It keeps everything in the backend clean. We do not need to break up this nice user service with logic that does not really belong into it. Thing is, you did not really solve the issue in this approach, right? You just shifted the complexity elsewhere where you don't have to deal with it in your microservices landscape. And it's probably also not the greatest idea because, first of all, you do not necessarily control all of that front-end code, right? If you deploy a web application, anyone can technically add some things to this code, or just call the API directly with the tokens you provide there. Additionally, since you're a high growth firm, right, and you want to reach as many users as possible, you're probably not going to have only one front end, right? You might have an iOS application, Android, and web application, and all of a sudden you created 3 times this code, and you're also not really technology agnostic, right? And you're constrained by the technologies that you can use on the devices that you want these frontends to be on. So, all in all, thinking about how much of the promise of microservices have we fulfilled here, um, we did get a lot of the upsides, but only for 30% of our code, right? Or like 40%. Only a small part of it. And the rest now lives in the front ends where it should have actually probably been in the back end. Now, next place that we can try to put it in is in the gateway or some other kind of horizontal component that sits atop all of these entity services. This looks better. At least we're not spreading it across multiple code bases. But what we're doing here now is we're having multiple teams put this process logic into one component, right? So we're not really doing microservices in this scenario. We're kind of doing some microservices with a mini monolith or a modular monolith maybe in the middle, but still we're not reaching to this promise of microservices. Additionally, we still have them not really independently deployable and scalable, because, and also not fault tolerant, because if one of those services is down, the user service, product service, or inventory service, since we need all 3 of them to process an order, and if one of them is down, we're down, right? Good or not so great. Where else can we put it? Like if we don't want to put it in one of those central components, maybe we put the logic into the services themselves. That way we could have all the ordering logic that touches the products in the product service. We could have all the ordering logic that touches the users in the user service, etc. But what we're doing here is we're already kind of getting into the land of the promises of microservices, but we're not really supporting our headcount growth here, for example, because now the team implementing ordering needs to touch 3 services, or rather 3 services need to implement ordering. Additionally, we're also not really fault tolerant, because if one of those services is down, all of it is down. No orders being processed. And question remains of whether they're really independently deployable and scalable, because if the whole process is spread across 3 services, if one of them gets hit by traffic, probably the other 2 do too. And therefore you can technically scale them independently, but they will scale together up and down. Right? And probably if you develop this ordering feature or change something in the ordering feature, you might need to change all 3 services and therefore 3 teams. Not ideal either. What else can we do? We could have a 4th microservice. We could, behind the gateway, add an ordering service, which then talks to our entity services. Now, this is more promising already, because here, depending on how mature or how stable the APIs of this user, product, and inventory service are, the ordering service is pretty free in changing its logic without requiring changes in downstream services. But it's still not independently deployable and scalable. It's independently deployable, but if the order service gets more traffic, everything else needs to scale up as well. And it's also not really highly fault tolerant, because if one of those services is down, no more ordering for our fledgling e-commerce business. Additionally, we have increased the complexity as opposed to the other solutions by one additional microservice. Now, so far, the entity services, they don't look very promising. We can make something work. We can get some of the benefits of a microservice architecture, but we're really not using it to its fullest potential. So we had some gains in team independence. We had minor to no gains in resilience, to be honest. We had minor to medium gains in decoupling, but all of that at the cost of quite some increased complexity. And we start to realize that these customer journeys, this ordering logic, is the one that's generating value for the customer, and that the value generation usually happens through entities interacting with each other, not through entities on their own, but through them, with them interacting with each other. Now, how can we do this differently? Maybe we should use these customer journeys as our main driver of our microservice slicing. We will still have entities. There's no way around it, right? Our business builds on products, users, and inventory. But we can assign them to different kinds of services. We can assign them to an account management service, an ordering service, and a vendor management service. They're not only responsible for their own entity, but they're responsible for a journey. Ideally, we would assign them one-to-one. Right? We would be happy if the product entity only belongs to the vendor management service and the inventory only to, say, the ordering service. But reality is usually more complicated than that. An order is done by a user, and he orders a product, and this order probably reduces the inventory somewhere. A vendor is also a user, and he sells inventories of products, right? If I have a product of white t-shirt, medium size, then a seller is going to offer selling 50 of them, for example, at a certain price. So what we try to do is we try to clearly assign one of those entities, or the right ownership of one of those entities, to the service that uses it the most. Right? And therefore, we get the highest benefit of assigning it to one service only. What could that look like? We could have an ordering service which owns the inventory, because it is the one that has the most interactions with an inventory. So we will have a seller offering to sell 50 t-shirts once, but I doubt that one user is going to buy 50 t-shirts in bulk. It's probably going to be sold to, say, 45, 46 customers, right? The account management service is going to be the one that's doing the most writing on the user entity, because it's the one that's going to change the user's address and his email address, etc. And the vendor management service is the one where the new products are going to be added, because we now get sellers of those products onboarded on the platform, and therefore it will be the one creating those. So what does this mean now for processing an order? Let's step through it. An order comes in, customer wants to buy 2 white t-shirts. He's one of those who buy multiple, right? And now the order service needs to know, is this customer eligible to buy them? And which is, with t-shirts, not that big of a deal, right? If it was tobacco or alcohol or something along those lines, that might be more important. And he needs to know, do I have inventory to sell it to that user? Well, the vendor is the one who offers the inventory, right? So he will have to tell the order service, hey, I have this many of white t-shirts to sell. And he does that before the order service even gets the request. And then the ordering service is going to, after he receives the request, check the account management service. Is this user eligible? Has he validated his account? Has he validated his email address, for example? And then the customer journey service is capable of responding. So this looks a bit better already. We do not have that much dependencies of these services on each other. we're depending on endpoints. The teams can change their logic autonomously. Yeah? So if something changes in the ordering logic and we need an additional step before a customer can complete an order, it's probably only contained within the ordering service, so we don't need to touch other teams. They are independently deployable and not so much scalable. Yes, they are, but we're still forwarding requests that hit the order service to the account management service in this case. And we're not really highly fault tolerant, because as soon as the account management service is down, the ordering service cannot process any orders anymore. Good, but we're already better. How can we improve this even more? We can start co-locating the data that the ordering service needs to process its orders. We can put that data into the ordering service already. So what does that mean? Again, we start off by customer wants to buy 2 white t-shirts. So he requests from the order service, can I buy those, please? What happens here before the order service is even hit is that the vendor management service, as soon as it is told, or as soon as somebody interacts with it and says, okay, there is this product white t-shirts and there is the seller who's willing to sell 50 of them, it is going to publish this information to some kind of message bus. So it says here, first of all, here a new product category, white t-shirts, and then it publishes a command and says, please add 50 white t-shirts sold by this company. The account management service does something similar. Whenever a new user signs up and he validates his email address, the account management service simply publishes that information to the message bus. And the ordering service knows, hey, I need this kind of information to be able to do my processing. So it reaches into the message bus and listens to those events and stores them in its own database. So at the time of a request hitting the ordering service, it already has all the data it needs to make this decision. And therefore, it's seriously a 1-2 step. I get the request, I can respond instantly. What have we achieved? We have decoupled the services because they depend on streams in a message bus, not specific implementations. We have highly autonomous teams because the ordering service team, the team owning that service, it can develop features and it can adjust the ordering customer journey as much as it wants without necessarily needing to talk to other teams and other service owners. It always needs to be said that the autonomy of these teams, it obviously has an upper limit, right? It has an upper limit with how independent are the underlying business processes from each other. Right? So if the vendor management service does not start publishing or does not start pushing how much it has on sale, nobody else is going to be able to access the inventories. Yeah. We are independently deployable and this time also scalable because we are not forwarding any pressure that hits this order service. So a request that hits the order service does not propagate the load to downstream services. It is only contained within the order service. We're still technology agnostic, as with a lot of the other approaches from before. And we're also highly fault tolerant in this case. So the account management service and the vendor management service, they can be on fire for all we care, as long as the inventory that we're selling, these 50 t-shirts, do not run out. We're fine. We can serve customers until we're out of t-shirts, and then we need the vendor management service to tell us that there are more to sell. And with that, we have a job well done. We have teams that can work fast without a lot of boundaries between teams being walked across for feature development. We're highly available and we're highly scalable. and we can become the new Amazon and send rockets into space. What have we learned today? From our point of view, from our experience, it is important to focus on customer journeys in your microservice slicing. Also, synchronous integration between microservices does not really allow you to fulfill the promise of fault tolerance in microservice architectures. So think of data co-location to increase the availability of your services. Do not over slice your services straight from the beginning. You will learn how to slice your services while you are working on the underlying business. And also, one team doesn't necessarily need to manage 7 microservices, right? They probably won't gain so much by it, but they will have a lot more work in handling the pipelines, the deployments, some of the code duplication, etc. All of that being said, architecture doesn't exist in a vacuum, right? We can make these nice slides here now, and the train of thought definitely does make sense, but it always needs to be applied to a specific organization to be able to make well-funded recommendations. And with that, the one-way street of information is nearly done. I want to thank you, and I have a couple more announcements to make here. First of all, you can find the blog post for this talk under this URL. The slides themselves will be shared afterwards, so you can actually click on the link. We also have another upcoming Brainfood Talk, which will be by my lovely moderator Ralph and our colleague Paul. And from May the 18th to the 20th, we will be hosting a Codecrafts conference in Vienna, and we'd be happy to have you join us there. And with this, I do now open the floor for questions.
So, yeah, I'm back here as well. So I will be taking some of the questions that you had in chat, and so yeah, thanks for the talk first of all, Clemens. So the first question is from Thomas. Ultimately, it's about querying data, right? So he asks, how do you deal with querying bigger chunks of relational data when you have this data distributed across different services, right? Like with their different databases. Like how do you deal with that scenario?
What we do about this is that we actually do not have the data distributed, right? What we do is let's go back to this slide here. We have distributed ownership of the data. It's not distributed, right? One team, one service owns a piece of data. It owns an entity, but the data does not live only in one specific service. So as we had in the example before with this with t-shirts being sold, the account management service, every time a new user signs up, it would publish something like a user document, which contains all the information to that user. And then the ordering service replicates this data in its own database. So with these IDs also being distributed, then the ordering service can build up its own relational database in a shape and with a database engine that serves its needs, to be able to fulfill its own requirements. And if you say have big data requests or big data processing that you need to do, then you will probably not write this data into a MySQL database, but you would want to use something more specific to big data processing, right? So then you would, in this picture, have your own service for, say, business intelligence or analytics, and they also subscribe to these events and documents in this case, and they can then run the big queries on top of that.
Cool, thanks. So the next 2 points, I would really maybe get your opinion on that. So I think it's from Mario and Matthias. They both mention the complexity of the message bus that we're now introducing. So Mario says, like, isn't the message bus now kind of our single point of failure in this system? Specifically, if you, for example, have a longer downtime than you would have in the rest of the services, for example. And Matthias mentions on top of that that while we achieve decreasing the complexities in the services themselves, right, we are kind of overall increasing our technical complexity to having to kind of maintain this message bus in terms of fighting against this single point of failure. So maybe you can just maybe elaborate your thoughts on that topic as
That is definitely true and good observation. The message bus does become our single point of failure, and some component will have to have high availability in this architecture, such as the same as the API gateway. It it is also a single point of failure, right? So we do not completely get rid of it in this architecture. We decide to trade downtimes of individual services not impacting us so much for this single point that we need to pay close attention to, not to let this one fail, right? It's right. If the message bus is down, the services can no longer talk to each other, and therefore our service quality will be limited. But on the other hand, if, say, this order service has all the data it needs to do its processing, then even the message bus being down is not a big bottleneck for it, right? But we do have to deal with the eventual consistency. So if you would block the user now at this point, and the account management service says, okay, no, this user is not allowed to purchase anything anymore, then the ordering service would not know about it in time, and it would probably allow this user to still make a purchase. Yeah.
cool.
I think that answered one of the questions. Yes, we have
Yeah.
a single point of failure, and yes, we need to make sure that one is highly available.
Yeah, so I mean, then on top of that, so ultimately the trade-off, or maybe I can add on top of that before coming to the next question. So I think like how is your kind of like gauging approach then while actually consulting people on top of like with regards to this architecture, right? Because as Matthias points out, well, we are reducing complexity in the services, right? But we are increasing complexity on the operational side for the message pass topic, right? So how do you like, is there an approach that you kind of follow when you are at this kind of point when you say, well, how do I gauge where we kind of put the needle down, right? Like where in the balance this falls. Can you maybe walk us through that a bit?
Yes. So again, this depends on whether you need the high availability of such a system and the performance of such a system, right? You can avoid the single point of failure if you go with a synchronous approach here, right? You do not have a message bus here, but you are multiplying the points of failure that could, or you're increasing the amount of points of failures that could break one single process, right? So you can't design around that. And still we're trying to reduce the amount of connections we have here always as much as possible, but we will not completely get rid of them, because as we said, reality is usually a little more complicated than we would like it to be. And so if this kind of read optimized performance and integration through a message bus, which increases availability, is not so important, then we do not need to add it to the architecture. We can still achieve a lot of the gains of a microservice architecture with this. But the difficulties of operating such a message bus can also be outsourced to different cloud providers who then guarantee us the availability, right? So we can make sure that somebody else takes care of having this highly available component actually highly available. Does that answer the question? I hope so.
Sorry, I was on mute. So thanks for that. There's a question with regards to the actual organizational setup. I will come to that in a bit. But first, it's still like there's another point on the data handling. So it's from RT, like he agrees that on the point that each microservices should own their own data, but then ultimately brings up the point of like in his opinion, like duplicating data across services is not ideal, and that multiple copies of the same data across the various nodes would just they just continue to grow, right? So in his
Mhm.
he says Saga, like the Saga with orchestration pattern is better here, where you know piece by piece construct data when it's needed, right? So maybe you want to share also your thoughts on that topic.
I hope I understand the question correctly. That goes more into this direction, right? So as you said, you have an orchestrator who then fetches the data needed to be able to fulfill this this saga. Um, is this better? That depends, right? Yes, we have data duplication in the co-located microservices, but we can keep the data in the format that we need it for, and also we can only keep the data that we actually need for it. This introduces, as we said before, it's less, you have less independent teams with this, or you have more layers of abstraction in this approach, where you need to have one middle layer of abstraction, which are the actual customer journeys, and then you have the entity services underneath it. And then you need to deal with all kinds of eventual consistency issues in this approach as well, right? So if the saga it fails midway through, then you need to revert all the changes made in the other services. So you're not, I don't think you're really avoiding a lot of complexity here. You're trading it elsewhere. Like you're, in my opinion, you're saving cost on the replication of the data, but I think you're absorbing a little more complexity in the actual orchestrating services. Because if you co-locate the data with um, with the customer journey itself, then you have less in eventual consistency to deal with, and the implications that this eventual consistency has. So yes, multiple valid options here. We have found that this one works best.
Cool. Thanks for that. I think we now have a point with regarding to the general, let's say, microservice slicing topic when it comes to the organizational side of things, right?
Yeah.
So, as Manuel points out here, so like maybe if you can just share your experience on that part, right? So so he asks, like, do you, in your experience, teams like lose touch a bit in between each other when becoming more autonomous, right? So it's a bit more about the separation of like the organizational separation in handling services individually, and what do you think, or what is your kind of, or what do you put emphasis on to kind of maintain this exchange and maintain this kind of still commonality in between the teams while now being more technically separate, right? So maybe you can just like muse a bit on that.
Mhm. It's a very good point, and this touches on architecture does not exist in a vacuum, right? In the context that we have created here, now we're trying to be a high growth e-commerce startup, right? And every synchronization across teams where they need to align and keep touch with each other are usually quite slow processes in delivering value. So here we are intentionally trying to keep this kind of alignment to a minimum. We are trying to keep the alignment to those topics that touch everyone, and that being, say, event structure and record structure that we put on a message bus. But whether they would like to have a strictly layered architecture, be functional, procedural, or have a hexagonal architecture inside or design inside of their own application, um, we can choose to have less of that, cross less boundaries, and therefore be faster inside of our own feature team. And so this, it enables us to do this. It does not mean that we necessarily have to do it, but it definitely leans more in that direction. And in this context, this is a conscious choice, right? We want that to happen. We want these teams to be decoupled and to work in whichever way allows them to deliver customer value fast without compromising the common component, that being the message bus. So we draw some very clear lines for where they're allowed to do whatever they want and where they have to comply with the rules that we set for design and architecture as a group.
Makes sense. I mean, ultimately, also there is not really an implication of who needs to staff what now, right? Because we ultimately just abstract different technical logic from each other in this case, from in between each other. So like, do you kind of like maybe from, let's say, a growing experience, right? Like ultimately, let's say we start out with a smaller team, and let's say our business grows a bit, right? Is there any points with regards to, let's say, splitting up, kind of like services grow bigger and over time, to kind of like also has, do you, in your experience, does that have kind of an organizational growth kind of aspect in terms of like maybe one team handling multiple services and then kind of distributing on the one side? So maybe a couple of points on that from your side, and also kind of what do you think of kind of let's talking about the contractual agreements between services, and ultimately whether it be through a bus or otherwise. What are your kind of opinions on that, or kind of like, let's say, like maybe there in terms of like contract based testing and so on, like do you maybe also have points on your experience on that? So maybe those 2 points, but also you can also maybe share a bit on that.
Let me try to untangle that. So the first one
Mhm.
was
About kind of the natural growth of services
yeah.
and the organization, like like caring, taking care of those services.
In my opinion, having many microservices right from the get-go inside of one team to then optimize for a potential team split later down the line is not the best approach. It falls into the category of premature optimization to an extent. And you're getting started with the business. You do not necessarily know where the real complexities are inside of a service. So in my opinion, you should stay with something where you can refactor easily and work with it quickly in the beginning. So stay with as little microservices as as many as necessary, as little as possible, right? So if you have one team and you're just starting out, I would recommend not to immediately have multiple microservices created, but to go for more of a modular monolithic approach. And then when you see good reasons to split it up, you have a bit of an easier time to do that down the line. But you might have some trouble if you already created 4 services and then you notice that one of them barely has any logic in it and another one grows quite massively, then you'll have to split that one up anyways. So better to do the split a little more retrospectively if you have the chance to do that, right? But on the other hand, if you see something or you already have experience, say you're a company that already has a lot of software and you're trying to replace something that already exists, we actually have a good talk on that by one of our colleagues. You can watch that on YouTube. And you already know that this is going to absorb a lot of complexity, then yes, it makes sense to go straight for having a microservice for it and then be able to hand that one over to the other team when it takes over, or if it takes over, right? So much I think on that. And team splits, in my opinion, are very natural, right? If an area of business becomes more complex, more engineers are probably going to be onboarded onto it, and then at some point you can split them up and give a part of them ownership of one part of the service, or have it become, actually you need to or should have it become its own service, and the other team then stays with the original. And then a second question was on the
With regards to
topic of
contracts. Hmm.
contracts.
Mm.
Yes, correct. Um, it depends what kind of system you have, right? So we have a good chunk of experience with Kafka and schema Kafka with the schema registry next to it. So there, the contracts are enforced by not necessarily by the message bus, but by a component that comes along with the message bus. So the need for a lot of contract testing is not given so much right? Because the contracts are enforced by the system itself. And then it comes down to you in your own service doing your due diligence and making sure that within the bounds of these contracts that are defined in an Avro schema, protobuf schema, or a JSON schema, ensuring that the values that can come within those you still validate. So there's still some work to be done by the individual teams, but a lot of it is actually taken care of by the infrastructure. If you cannot ensure that, then yes, you need to pay more attention to contract testing, right? If you have different kinds of infrastructure you build on top of.
Right, makes sense. So ultimately, we're kind of deferring there to the technology below, so that we're utilizing to kind of help us out with that. And if we cannot, we need to, of course, kind of have some, let's say, workflow put in place to actually like handle the topic there. Great. I can actually see there's a good discussion already going on in chat with regards to the points we had before about data duplication. So that's cool to see. Herbert also asked, what is the difference to event sourcing? I assume that is the case also regarding to that discussion. So
With event sourcing, I have to defer a little bit because I do not have the expertise on that. But as far as for my limited, not limited, but for my limited touch points with event sourcing, the way I understand it is that you do not publish so many documents. So a document contains the finished state or the current state of an entity, right? So if we talk here, the account management service registers a user or a user changes his email address. I publish a document, which is the new state of this user, like the complete new state with email address, name, first name, last name, etc. Right? And in an event sourcing system, I rarely do that, but I publish state changes. And then the event sourcing system or the event sourcing logic that I have, be that from off the shelf system or I rebuild it myself, that then collapses all the events down to get to this finished state that I have. So in the way I understand it is it puts more logic into the message bus itself, and then has these services depend on a common data model inside of that message bus, and they would then, like if they want to optimize it for their own purposes, would have to still map it to what they require of that data. But you have like a common shared data model in the event sourcing system.
okay, cool. Well, I think we are through the questions. There are no more open questions in chat now. Again, so like of course, if there is anything else that comes up after the talk, I guess Clemens and everybody else here at Square will be very much happy to help or have discussions. As RT points out as well, it would be nice to have maybe a longer session on maybe the wider topic. So maybe that's something that's coming up in the future as well. So great to see some discussions here in chat as well. If you're interested in anything further, in the video descriptions, you can find some more reading material as well as a blog post with regards to this topic. Of course, you can also see the presentation itself as a link there. It's basically hosted on our homepage. And you can also have a link to our further upcoming Brainfood Talks. Again, I mentioned it's a monthly installment, basically. So there's some good content in the pipeline upcoming for you guys as well. So yeah, just check out the links in the description. And yeah, with that, thank you, Clemens, and we would be signing off then. Thank you, everyone. Thanks for tuning in, and hope to see you at the next Brainfood Talk as well. Take care, everyone, and stay healthy. Bye bye.